Hi guys. Okay, this is going to be my other property I'm going to show you how to do with exponents. This is called the quotient property. We know the word quotient means division. Before we start, I just want to review something really quickly. If I had the fraction 2 over 2, we know that would simplify to 1. This is going to be happening when I'm writing out an expanded form, and I'm going to represent it this way, but I just wanted to make sure that you understood that I'm not canceling out those 2's. I'm showing that they simplified to 1. So that's what that means. Also, how cool is this pen? Okay, so I'm going to do this first problem, 2 to the 6 over 2 to the second. So, when writing this out in expanded form, in my numerator, or in the top part of my fraction, I have 6 2's. So I have 2 times 2 times 2 times 2 times 2 times 1 more 2. Then, in the denominator, I have 2 to the second. So I just have 2 squared, or 2 times 2. Now this is where I'm going to simplify. I notice I have a 2 over a 2, so these two become a 1. These also become a 1. I can't simplify anything else, so I'm done. Again, you always keep your base. And how many 2's were left over? 4 were left over. They were left over in the numerator. So really I'd have 2 to the 4th over 1, but we know we don't really have to put the 1, so my simplest exponential form would be 2 to the 4th. The next one I'm going to do is this one. I have x to the 4th on the top. So in my numerator I have x times x. I'm going to have 4 of them since my exponent is a 4. Then in the denominator I have 6 x's, so I'm going to show that by showing the multiplication of 6 x's. Now, again, I'm going to simplify. X over x would give me 1, 1, 1, and 1. I can't simplify anything else, so let's see what I have left over. I have no more x's in my numerator. So I have to have something in the numerator. I have to have a placeholder. So I'm just going to put a 1. That will always be your placeholder. If you have nothing left over, put a 1. Just like we did in the first problem, we had nothing left over in the denominator, so we put a 1 down there at the bottom. Now, in my denominator, I notice I have x, 2 x's. So I'm going to have x to the second. So this is how I'm going to leave my problem. You can only get rid of the 1 if it's in the denominator. I always have to have something in my numerator. So I have 1 over x to the second. Again, I need you to figure out what is the rule. There is a pattern happening. There is something happening. So you need to figure out what conclusions can you draw that's happening when we're dividing these exponential expressions. Also, I just want you to see, does this same rule apply to the coefficients or the big bases out in front? So right now, pause the video. Don't just play through it. Actually pause and try to figure it out. You need to complete all of these problems and put them in their simplest form and show the expanded form. Again, you're not going to be able to figure it out, guys, if you do not do that. So pause the video and try that right now. Okay, so if you hear me, this means that you've already solved all of those problems up top and you've written them out in the exponential form and you know what the conclusion is. You should have found out that you're subtracting the exponents. So you subtract exponents that have the same base. And I'm going to show you what I mean. Same base. So if I had the problem x to the 3rd over x to the 2nd, those both have the same base of x, and 3 minus 2 is 1, so my final answer would be x to the 1st. Now my second problem, I asked, does this apply to the coefficients? So if I had a problem 10x to the 3rd over 2x to the 2nd, you would not subtract 10 and 2. You wouldn't say that it's 8. You're going to use these just like you normally would and simplify like normal. So 10 divided by 2 is 5, or you could simplify 5 over 1. It only works for the exponents. Then I'd have x to the 1st. Okay? I want you to notice when you have a bigger exponent on the bottom, like we did over here, my answer ended up in the bottom of the fraction. 6 was bigger, my answer ended up at the bottom. In my first problem, the bigger exponent was 6, and my answer is in the top of the fraction. So I'm going to show you just 2 more to make sure that you get it. So I'm going to do number 7. And I'm going to go back to this pen I really like. There isn't an exponent by this 8, so I know that it's really the exponent of 1. And I'm going to subtract. I'm going to have 8, 1 minus 3. And you can think of this in absolute value. So that's going to be a 2. 3 minus 1 is 2. Where was my bigger exponent in the first original problem? It was in the bottom. So my answer goes to the bottom. Okay, this was the biggest exponent. So my answer ended up down here. I'm also going to do problem number 12 with you. Okay, I notice I have these 2 whole number coefficients out here. The 2 over 6, I do not subtract those. I'm just going to simplify 2 over 6 like I normally would, and that gives me 1/3. Now I continue with the exponent rule I just found. This a has an exponent of 1. 3 minus 1 is 2. 3 is my biggest exponent, so my answer goes to the numerator. You could write it like that, or you could put this. It does not matter. They mean the same thing. Okay, you need to complete the rest of this handout. Remember, in quotient property, you subtract the exponents with the same bases.